Let's take a closer look at CVE 2019-5736. This is a high-severity container escape vulnerability, scored at 8.6 on the CVSS scale. Essentially, it allows an attacker to overwrite the runc binary on the host, which can lead to them gaining root access outside the containerized environment. This vulnerability impacts several products, including Docker versions prior to 18.09.2, runc versions before 1.0 or C6, and by extension, other container management solutions like Kubernetes and LXC that use runc. CVE 2019-5736 was first reported by security researchers Adam Iwaniuk and Boris Poplawski, and a patch was officially released on February 11, 2019. If you're running any of the affected versions, it's critical to update to patched versions to prevent potential exploitation. This vulnerability demonstrates how important it is to keep container runtimes up to date, as an exploit here goes beyond just affecting the container, it threatens the security of the entire host system. CVE 2019-5736 is a significant vulnerability that targets container environments. Specifically, it enables attackers to overwrite the runc binary on the host by leveraging certain capabilities available inside containers. The exploitation method takes advantage of how the container runtime interacts with the /proc/self/exe file descriptor. By manipulating this mechanism, an attacker can execute commands as the root user on the underlying host system. This vulnerability applies in two main scenarios. First, an attacker can spin up a new container that uses a specially crafted image designed to exploit this weakness. Second, if an attacker already has write access inside an existing container, such as through the docker exec command, they can also trigger the vulnerability. In both cases, the result is unauthorized privilege escalation that can compromise the entire host. Let's walk through how attackers can exploit CVE 2019-5736. There are two primary attack vectors. First, an attacker might create a new container based on a malicious image they've crafted. Alternatively, they could attach to an existing container and execute harmful commands if they have sufficient access. The typical exploitation strategy involves replacing a target binary inside the container like /bin/bash with a malicious script that references /proc/self/exe. The script essentially points back at the container's runtime process. By manipulating file descriptors in a specific way, the attacker is able to overwrite the runc binary on the host. This usually happens when the original container process halts, allowing the attacker's code to run with elevated privileges. This method effectively provides the attacker with root-level command execution outside the container, compromising the host environment. This slide outlines the primary products and environments affected by CVE 2019-5736. The vulnerability impacts major container runtimes, specifically Docker versions before 18.09.2, as well as runc versions prior to 1.0 or C6. These runtimes are widely used in various platforms, so Kubernetes clusters that depend on these vulnerable versions are at risk. Additionally, many cloud services leveraging Docker and runc in their infrastructure can be exposed if they haven't applied the necessary updates. It's crucial to recognize the broad scope of this vulnerability, as it extends beyond local or isolated environments and can potentially impact large-scale deployments across multiple cloud providers. Here's how you can address CVE 2019-5736. The first and most important recommendation is to update your container runtime software. For Docker users, make sure to upgrade to version 18.09.2 or later. If you're using runc directly, upgrade to at least version 1.0.0 or C7. These versions include patches that resolve the vulnerability. Beyond updating, there are several mitigation strategies you can implement to reduce risk. Avoid running your containers as the root user whenever possible. Enforcing non-root execution is a best practice because it limits the potential impact if a container is compromised. Additionally, using user namespaces helps to isolate container processes from the host, adding another layer of security between your containers and the underlying server resources. Incorporating these changes improves both your security posture and container management processes. On this slide, you'll find a curated list of references and additional readings to deepen your understanding of CVE 2019-5736. The National Vulnerability Database entry provides a detailed overview of the vulnerability, while the GitHub link includes publicly available exploit code for further analysis. The Red Hat advisory outlines vendor-specific guidance, and the AWS Security Bulletin highlights cloud-focused mitigation steps. Lastly, the Kubernetes blog offers insight into how the vulnerability affects orchestrated container environments. These resources will help you stay informed and support your efforts in managing security in your containerized workloads. CVE 2019-5736 is a strong reminder of the importance of effective container security management. To mitigate such vulnerabilities, it's crucial to keep your environments updated and patched regularly. Adopting security best practices like leveraging user namespaces and running containers as non-root users adds extra layers of protection. Implementing these measures helps you reduce the attack surface and improve your overall security posture when working with containers in any environment. This slide highlights the benefits of presenting security vulnerabilities in a clear and concise format. By focusing on the key points, we can make complex issues like CVE 2019-5736 more accessible and understandable. This approach not only helps participants grasp the critical aspects of the vulnerability, but also encourages practical discussions on mitigation strategies. Making the information digestible is especially important in a cybersecurity training session, where participants need actionable knowledge to apply effective security measures in their own environments.